All right. But right now we're just using this as a kind of a bookkeeping system. Okay? We're just going to keep up with our electrons in these boxes. So the electron, the one electron in hydrogen, we're going to show as an arrow pointing up. And I like half arrows just because it's faster. You can draw a whole arrow if you want. Okay? But we always start with the first electron represented as an up arrow. Okay? All right, so that's the orbital notation for hydrogen. Elemental symbol, colon. This 1 means that's the first primary energy level. These electrons right here in this first circle. S tells us what sublevel. And within that sublevel, we got these orbitals. Orbitals are boxes, and the electron is an arrow. All right, that's a lot to throw at you, right? But we'll practice with them. We'll keep going until we get good at it, okay? So that's hydrogen. Let's do helium. Okay, so here's helium. It's right over here. So let me give you another heads up. The periodic table's kind of arranged the way it's arranged because for most things we use it for, it makes the most sense by doing it like this. But some of the time, helium doesn't really belong here. Some of the time, helium really belongs here. Okay? And this is one of those times. Helium belongs here much, much more effectively. It's better to understand what's going on if we put helium here to understand about these sublevels and things. Okay? Because if we put helium over here, then these first two columns represent all of our S sublevels. You got that? If we put helium here, these first two columns represent all of our S sublevels. All right? So just kind of keep that in mind. So helium is, again, on this first circle here. So that's primary energy level 1. And since helium's in these first two columns, and that represents our S sublevel region, then the electrons for helium must also be in S. That make sense? So far? Well, sort of, kind of, because it's kind of all new, isn't it? Okay. All right. All right. And both our electrons are going to go in this orbital. There's only one S orbital in any primary energy level. Only one S orbital in any primary energy level. So there's in the first primary level, there's only one S orbital. And orbital is represented by our box. Okay. So we have 2 electrons for helium. This 2 means there are 2 protons in helium. If you have 2 protons and an atom of helium, then you also have 2 electrons. All right? There's our first electron, and our second electron is going to be pointed down. Okay? All right. Now, why do we do 2 arrows pointing in opposite directions? Huh? Wow, very good. So we're going to put 2 electrons in the same orbital. And electrons have what charge? Negative. So they should repel each other, right? But they don't. Okay? If we were nuclear physicists or quantum physicists, we would explain this in terms of quantum entanglement. Okay? The 2 electrons in helium are quantumly entangled. I can remove this electron from helium, according to theory, and move it somewhere on the other side of the solar system, and they're still going to be talking to each other. Sort of. They don't really talk. Okay? But the spin of the first electron is going to be the opposite of the second electron because they are quantumly entangled, even if we remove them from the same orbital. Okay? Until one of the electrons comes close to another electron, and they become quantumly entangled. Now, we're not going to deal with quantum entanglement here because that's not chemistry. It's physics. Okay? But that's, if you ever see anything on TV or hear something about quantum entanglement, it's a big deal in physics. That's what it's all about. We're going to talk about it in terms of spin. Okay? Now, in order to get 2 electrons in the same space, inside the same orbital, we've got to do something about that supposed repulsion. They should oppose each other. Okay? Well, This is where it's kind of neat. This is kind of like your doorbell at your house, or the what makes your starter engage with the engine in your car, or what turns the valve on to let the water in your washing machine. Okay? If I spin one electron this way, that is, going around like this, okay. If I spin the other one in the opposite direction, so the theory goes, we cancel the repulsion. They can be together. Okay? And the reason I say it's kind of like your doorbell works with the same thing. It has something called it's kind of like a solenoid. We've got these wires that go around in a circle like this. Okay? And the electricity running down a wire has an electromagnetic field that runs in the same direction as your fingers on your right hand. So if your thumb points the direction of the flow of electrons, the magnetic field goes this way. Okay? And if you put it in a circle, the magnetic field goes right down the center of everything, in only one direction. So if I have this circle of wires, round, and I turn on the electricity, I'm going to get a magnetic field that sends a magnet going through the middle. And that'll make your doorbell ring. It turns on the water, it turns off the water on your washing machine, and it's what makes the starter engage in your engine. Okay? Basically the same kind of idea. It's related to physics in a very, very strong way. Okay? This spin creating a magnetic field or canceling a magnetic field when you have it in opposite directions is why we use coaxial cable to hook your TV up to an antenna or to the cable or to the satellite. Okay, because you've got a wire coming down the middle of coaxial cable and a braided wire going down the outside. And so the signal comes in, down the center, and out around the braided wire, and it cancels the electromagnetic field. That makes sense? Because one end has the signal going this way, one goes the other way, they break each other up, kind of like electrons spinning in opposite directions. So you can think about, there's a lot of things that are really more complex about electrons, but it kind of helps you if you kind of understand both of those. That makes sense? So when you take physics, you've already got a leg up on everybody, okay? You kind of know about this electromagnetic field and the right-hand rule, okay? Electrons moving in this direction, the field moves in the direction of the fingers in your right hand, okay? We have an electromagnetic field around the Earth. Keeps us alive. Y'all know that? You knew that? Why is that? Why do we have an electromagnetic field around the Earth? Huh?
So it wouldn't fall.
So it wouldn't fall?
It'd keep in place.
What are you saying?
What are we talking about?
You're thinking about the Earth going around the sun, I think, right? And the rate at which it falls is equal to the rate at is balanced against the not angular momentum, but the forward momentum. So it's keeping it out away from the sun. Okay. No, what I'm talking about is why it is that the radiation from the sun doesn't kill us. Okay, we have a magnetic field around the Earth. It's why we have the aurora borealis. Anybody ever heard of that? The northern lights. Okay. Well, the reason why we have this magnetic field around the Earth is because, the theory goes, our nickel iron core is spinning inside the Earth. And that spin is creating a magnetic field. We're not canceling one, we're creating one. That magnetic field then keeps this radiation that would otherwise kill most of the life on our planet, kind of keeps it at bay. And because it has a kind of a funnel shape at the North Pole, it funnels in some of that radiation, and we get these beautiful northern lights sometimes a year. Oh, it's kind of neat how it all ties together, right? Y'all aren't amazed? I'm amazed, and I know about it. I've known about it for years, you know. Anyway, okay. There we go. Opposite directions of spin, canceling magnetic fields, they can fit them in the same orbital. Got it? All right. Now let's go to lithium. Lithium is in a new primary energy level. This first row on the periodic table means that these electrons are in the same energy level right here. Lithium then is going to have these two electrons plus one in the second level right here. Okay? So here's lithium. And our first two electrons are in the first primary level. Okay? There's only one orbital, or one sublevel rather. There is one orbital. Right now I want to talk about the sublevel. There's only one sublevel in that first primary energy level. That's an S sublevel. And S sublevels only have one orbital, so we've only got one box. Okay, I can only put 2 electrons in there because I can only have 2 opposite spins. Got it? Quantum entanglement only applies to 2 subatomic particles. So here's our first electron. Here's our second electron. How many electrons does lithium have, though? 3. So I need to have another electron, but I can't put it in the first level because I'm locked out. I got to go to the second level. So now we're in 2. All right. These first 2 columns represent the S sublevel. Lithium is there. So we must be putting these electrons in 2s. Okay. Need a box. And since I only need one more electron, I just need one arrow. And we always show the first arrow is up. Up, by the way, is relative. Doesn't really mean up. Doesn't mean spin in this direction. But it's the way we represent quantum entanglement when we're doing orbital rotation. You with me so far? All right. Anybody going, OMG, how can I do all this? Nobody yet? You're okay? Good. All right. Cool. Then let's do beryllium. Do you think you could do beryllium by yourself? Based on what you know? Huh? Huh? Okay. There you go. There's beryllium right there. Try it and see. If you're writing in pencil, it'll be better. Because if you're in pen, you might just scratch it out and start over. If you're in pencil, you can erase it if you need to. See if you can predict the orbital rotation of beryllium based on what we've talked about so far. Okay? Who needs more time? All right, let's see how you did. Let's fire this up a little bit so I can have my periodic table down here so you can see. All right, so we're still going to have the electrons in those lower levels, okay? Those 1s1 and 1s2 electrons, okay? Let me put my colon here. And I have an orbital in the first primary energy level and the S sublevel, and I got 2 electrons there. And then beryllium is in the second primary level, so I got electrons in the second level, and the first energy level, sublevel we come to is always going to be S because that's where we start over here on the left-hand side. Left-hand side of the periodic table is always starting in the S sublevel region, okay? All right. So now I need an orbital here, and S sublevels only have one orbital. So I need 2 more electrons because beryllium has an atomic number of 4. That means 4 protons, and as long as we have a beryllium atom, we also have 4 electrons. So there's the same electron, at least we have for lithium, plus I got to have 1 more. How did you do? All right, I see some thumbs up. Good. Anybody doesn't quite understand and need a little help? I have a question. All right, good.